Everyone, and welcome to lesson 4.2, day 2. Today we are going to talk about equilateral triangles. Now, equilateral triangles are isosceles triangles because they have at least two congruent sides, but they take it a step further where we have three congruent sides and three congruent angles. So each time you have an equilateral triangle, you know all of the sides are congruent to each other, as well as all of the angle measurements are congruent to each other. So, for instance, in an equilateral triangle, we know for sure that the angle measures will always be the same amount because they have to, if you have an equilateral triangle, you know that your angle measures then will also be congruent to each other. So, if we divide up the 180 degrees that are in that triangle by 3, we know that each angle in an equilateral triangle is always going to be 60 degrees. You also will see that equilateral triangle is called equiangular for that fact. Now, in example B, they're telling you we have this equilateral triangle. And again, we know it's equilateral because these three angles are the same size marked on the picture. So we know all three sides will also be the same size. We want to find the values of x and y and find the lengths of our sides. Well, let's start with y. We know again that in an equilateral triangle, all of our angle measurements have to be 60 degrees. So we can take 5y and set it equal to 60 degrees because again, we know each of those angles have to equal that. So if we divide 60 by 5, we get our y value to be 12. Now the x values, again, they are giving you two sides, and again, all three sides are congruent. So if they had given us all three, we could have just picked our favorite two, but this time we're going to use the 5x minus 6 that they gave us, and 3x plus 2 was also given. We're going to set those equal to solve for our values of x. So plug this back in. 5x minus 3x is 2x's, and then we still have 2 over here. Add the 6 to both sides. We get 2x equals 8. Divide by 2, x equals 4. Now when we plug 4 back in, we have 3 times 4 plus 2, that's 14. And then 5 times 4 minus 6, again, will also be 14. But I like to plug it back in just to double check that I solved correctly. They should come out to be the same. The third side, again, will have to also equal 14 because in our equilateral triangles, all three sides are congruent. Right, down at the bottom, we have another example for you to try. The triangle is equilateral. What are the values of x and y? Now, moving on to the back side, we have another example. Given this triangle is equilateral, notice again they are giving us side lengths. So I'm going to label, again, these are the sides. So 9x minus 135, negative 4x plus 99, and 81 minus 3x. Okay, and because, again, this triangle is equilateral, we know we are allowed to mark all three sides congruent. They want us then to find the length of each side. Now, in this situation, it does not matter which sides we choose. You could pick your favorite 2 out of 3 sides to set equal to each other. I'm going to just choose to do 9x minus 135 and 81 minus 3x. Okay. Again, though, officially you could do either of pick your favorite 2 because they all should be equal to each other. So pick 2 out of 3. In this case, negative 3x is actually smaller than 9x, so I'm going to add that over to start. I get 12x minus 135 equals 81. Add the 135. I get 12x equals 216. And when we divide by 12, x ends up equaling 18. Now, this question wants us to find the length of each side, though. So again, we need to plug back in because we need to find TA, TR, and AR's lengths. So 9 times 18 minus 135 is 27. 81 minus 3 times 18 is 27. And AR, negative 4 times 18 plus 99 equals 27. So we get all three of those. And again, it makes sense that they're all equal because it is an equilateral triangle. All right, the next one, you have triangle try that's equilateral. You will do the same process. You are solving for the length of each side. Find x first. All right, down at the bottom, we have final two examples. The first one, we have a quadrilateral coug, and we want to find the side length of CG. We're going back to what we talked about yesterday. Reminder with these isosceles triangles, notice they marked these two base angles congruent to each other. They marked that on our picture for us. So we are allowed to say then, because of that, that the opposite sides of those base angles have to be congruent to each other. So side OC is going to be congruent to side UC. And then we also know over here that all three of these sides, this is equilateral. Notice they marked all three angles congruent, so it's equiangular, which means all three sides are going to be congruent. So this already has one tick mark. These will also have one tick mark because they must match. So if the side O to C was 33, U to C also has to be that same amount because, again, these are congruent. And then we know these other two sides will also have to be congruent as well and be 33. So if we look at the question, they want the length of C to G, it would be 33. Now, in our second example, notice again they are marking this is an equilateral triangle. All three sides are congruent, and we know that all of these angle measures would measure 60 degrees because of that. Now, that also being said, notice around here, these angles, all these triangles, again, are going to measure 60 degrees. So for the value of y, again, in that equilateral triangle, they're all 60 degrees. As far as the sides, then, we have 4x and 40. Those have one tick mark apiece, so we set them equal. Divide by 4, we get x then to be 10. All right, there's one last example for you to try. You are finding the length of side BU of that quadrilateral. And thanks everyone for watching. More in class.